Hi guys, this video is for the review for the second quarter, fourth week assessment in integrated math. Let's start. For number 1, if triangle ABC is similar to triangle DEC, what is the measurement of side DE? Okay, to better visualize the problem, I can separate the two triangles. So as you can see here, we have two triangles. The big triangle is triangle ABC and the smaller triangle is triangle DEC. So I'm going to separate them. Okay, so we have triangle ABC and triangle DEC. Based on the figure, side AB measures 15 and side AC measures 25. In the smaller triangle, side DC measures 5 and we are looking for side ED. So I can just name side ED as DE as X. Okay. So since they are similar, I can create a proportion wherein this side AB measures 15 over AB over AC, which is 25, is equal to, so side AB corresponds to side ED, okay, which is X, over side AC, which is 25, corresponds to side DC, which measures 5. So this is the proportion that we created. We can cross multiply 25 times X and 15 times 5. So we have 15 times 5 is equal to 25 times X. Okay? So 15 times 5 is equal to 75. And 25 times X is 25X. In order to solve for the value of X, we have to divide both sides by 25. So 25 divided by 25 is simply 1 or simply 1x. And 75 divided by 25 is 3. So we know that based on our solution, the value of x is 3. So the measure of ED is equal to 3, which is letter A. Okay, for number 2. In the figure below, if the measure of YZ is 20 and the measure of WZ is 8, what is the measure of XZ? Okay, so we are looking for the measurement of XZ. Okay, so to better understand this problem, we're going to separate the two triangles again, wherein we have the big triangle, which is X, Y, Z, and the smaller triangle, this one. And the smaller triangle is Y, W, Z. Okay? We have Y, W, Z. In the big triangle, YZ measures 20. And we are looking for xz. Okay, so let's say xz is a. Okay, and in our small triangle, yz, which is the hypotenuse of the small triangle, measures 20, and wz measures 8. Okay. Since these two triangles are similar, we can create a proportion wherein xz over yz is equal to 20 or yz over wz. So we can create a proportion a over 20, this side, a over 20, and xz corresponds to yz, which measures 20, and yz corresponds to side wz, which measures 8. Again, I'm going to repeat. xz over yz, which is a over 20, corresponds to yz over wz, which is 20 over 8. So this is our proportion. Again, we have to cross multiply 8 times 8 and 20 times 20. 8 times 8 is 8a, is equal to 20 times 20. So we have 8a, and 20 times 20 is 400. In order to solve for a, we can divide both sides by 8. So a is equal to 400 divided by 8 is 50. Okay. Which means that xz, or our a, measures 50, which is letter B. So the measure of xz is 50. Okay, let's go to number 3. In triangle ABC is similar to triangle DEF. What is the measurement of DF if the measure of side AC is equal to 9 inches, and the measure of BC is 12 inches, and the measure of EF is 4 inches? In order to solve this problem, it is easier to draw the two triangles, the triangle ABC and triangle DEF. Okay, so if I'm going to draw this triangle, so I have two triangles. Let's say I have triangle ABC and I have triangle DEF. So the question is, what is the measurement of DF? Let's say DF is X, and then the given is that the measure of AC is 9 inches, the measure of BC is 12 inches, and the measure of EF is 4 inches. Since these two triangles are similar to each other, we can create a proportion wherein we can compare BC over AC is equal to EF over DF. So we have 12 inches over 9 inches is equal to, so 12 inches, this side corresponds to side EF, which measures 4 over AC corresponds to DF, which measures X. So 4 over X. Okay? So applying cross multiplication, we have 9 times 4 and 12 times X. 12 times X is 12X is equal to 9 times 4 9 times 4. So 9 times 4 is 36. Bring down 12x. Since we are solving for x, we can divide both sides by 12. So x is equal to 36 divided by 12 is 3. So we now know that x is equal to 3 inches, which is letter D. Next, for number 4, triangle LMN is similar to triangle XYZ. In the figure below, what are the measurements of side YZ and side XZ? Okay, so since these two triangles are similar to each other, we can compare the sides. So we can get the ratio of, we have here LM and XZ. Since LM corresponds to XZ, we can compare their sides, wherein we have 10 over 4, and 10 divided by 4 is equal to 2.5. It means that the ratio of the sides is equal to 2.5. So now that we already have our ratio, which is 2.5, now we can solve for the missing sides, YZ and XZ. Based on the figure, MN corresponds to XZ. Therefore, in order to determine the measurement of side YZ, all we have to do is to divide 15, this side, divided by the ratio, which is 2.5. So 15 divided by 2.5 is equal to 6. Therefore, the measure of YZ is equal to 6. We can do the same thing with XZ. As you can see in the figure, side LN corresponds to side XZ. So since the measurement of side LN is 9, all we have to do is to divide 9 divided by the ratio, which is 2.5. So 9 divided by 2.5 is equal to 3.6. It means 3.6 is the measurement of side XZ. Okay, so now that we know the value of YZ and XZ, YZ is equal to 6 and XZ is equal to 3.6, which is letter C. Okay, let's go to number 5. A man who is 6 feet tall cast a shadow that is 8 feet long. At the same time, the tree is 16.5 feet tall. The question is that what is the measure of the tree's shadow? Okay, as you can see here, we have two triangles here. We can assume that these two triangles are similar to each other. Therefore, we can make a proportion comparing the height of the man and the tree and the shadow cast by a man and the tree. So we can create a proportion 6 feet over 8 feet. Six feet over 8 feet is equal to, so the height of a man corresponds to the height of a tree, which measures 16.5. So we can say 6 over 8 is equal to 16.5 over the shadow cast by a man corresponds to the shadow cast by a tree. And that is unknown. So we can say that it is x. So this is our proportion. So again, we can cross multiply this. Wherein 6 times x is 6x is equal to 8 times 16.5. So bring down 6x. 8 times 16.5 is 132. Divide both sides by 6. And 132 divided by 6 is 22. So it means that the measure of the shadow casted by a tree is 22 feet, which is letter A. Okay, for number 6. The foot of the ladder is placed 6 feet from the wall. If the top of the ladder rests 8 feet up the wall, what is the length of the ladder? So in order for us to visualize the problem, it is better and easier to draw the problem. Wherein we have a wall. We have a wall and we have a ladder. Okay. So based on the problem, the foot of the ladder is placed 6 feet from the wall. So if this is the wall, the measurement of from the foot of the ladder to the wall, it measures 6 feet. Okay. And the top of the ladder rests 8 feet up the wall. So the top of the ladder, this is the top of the ladder. It is 8 feet up the wall. So this is 8 feet. So the question is, what is the length of the ladder? So based on our previous discussion, we can see a right triangle here. Wherein this are the two legs and we are looking for the diagonal, which is the hypotenuse. Okay. Therefore, we can use the formula of the Pythagorean theorem. C squared is equal to A squared plus B squared, wherein C is the hypotenuse or the measurement of the ladder. So we have C squared is equal to the measure of the two legs. Let's say 6 feet is our A and 8 feet is our B. So we will have A squared is 6 raised to 2 plus B, which is 8 squared. Okay. C squared is 36 plus 8 squared is equal to 64. And 36 plus 64 is 100. In order to cancel the square, we can apply square root property, extracting the roots to both sides of the equation. So C is equal to square root of 100 is 10. Therefore, the value or the measurement, the measure or the length of the ladder is equal to 10 feet, which is letter C. Next, for number 7, if triangle ABC, in triangle ABC, BC measures 8 centimeter. What is the measure of AB? Just a quick review. This triangle is a 30, 60, 90 triangle. 30, 60, 90 triangle. Because if we have 30 degrees, 90 degrees, therefore this measures 60 degrees. Okay. So in this problem, we are looking for the AB, which is the hypotenuse of the right triangle. And again, quick review in a 30, 60, 90 triangle. Since this is the short leg, this is considered as our S, and the hypotenuse is twice the short leg, or 2S. And the long leg, which is the opposite of 60 degrees, this is S square root of 3. Therefore, since we are looking for the hypotenuse, which is 2S, and the S or the short leg is already given, which is 8 centimeter, we can use the formula 2S. So we have 2 times our short leg, which is 8 centimeter. So 2 times 8 is equal to 16 centimeters. That is the measure of the side AB. And the correct answer is letter B, 16 centimeters. For number 8, Tristan has a square backyard. If one side measures 10 square root of 2 feet, what is the measure of his backyard's diagonal? So again, to better visualize this problem, we have to draw the problem. So we have a square backyard. Okay. And this is the diagonal. And based on the given, if one side measures 10 square root of 2 feet, one side is 10 square root of 2 feet, what is the backyard's diagonal? Okay. So since this is a square, therefore we created 2 triangles wherein the corner is 90 degrees and the other 2 corners measures 45 degree and 45 degrees. So we created a 45, 45, 90 triangle. And in just a quick review, in 45, 45, 90 degree triangle, the side is RS, and the diagonal or the hypotenuse is S square root of 2. So since we already have our S, which is 10 square root of 2, we can solve for the hypotenuse or the S square root of 2. Using the formula, we have S square root of 2. Substitute the given. Substitute the value of S, which is 10 square root of 2. We will have 10 square root of 2 times square root of 2. Okay. So again, S, the measurement of S is 10 square root of 2 because this is the side, and then square root of 2 is this one. So 10 square root of 2 times square root of 2, it will become 10 square root of 4. And square root of 4 is equal to 2. So it will become 10 times 2. And 10 times 2 is equal to 20. So the correct answer is 20 feet or letter D. And for number 9, the last number, list the angles of the triangle in order from smallest to largest. As you can see in this figure, we have triangle M and P, wherein the given are the sides of the triangle. We have side MP, which measures 10, PN, which measures 16, and side MN, which measures 18. So based on the theorem, as you can see, we have side MP, which measures 10. This side has an opposite angle, which is angle N. Therefore, we can say that angle N is our smallest angle, because angle N's opposite side is side NP, which measures 10. And 10 is the smallest side, or the shortest side from all the sides of a triangle. So angle N. So we have angle N. Next, after 10, we have 16, which is side NP. Side NP's opposite angle is angle M. Okay? So after angle N, we have angle M. And lastly, the longest side is side MN, which measures 18. So this side is opposite of angle P. Since this side is the longest, therefore, the angle opposite is the largest, which is angle P. So from smallest to largest, we have angle N, angle M, and angle P, which is letter C.